There is another one more transformation, which is, I would say, slightly complicated, similar to your greatest integer function, but something which had come in your advanced competitive examination and is something which you need to know. The transformation is called as the fractional part of the function transformation. See, the origin of this transformation is the fact that I wanted to create a new function, or I want to transform the existing function to a function wherein it's repetitive in nature. Repetitive means after a particular interval, the function repeats itself. And it repeats itself in such a way that only the values of the function from 0 to 1 is applicable. Right? That's the idea of the fractional part of it. Let me explain it by using an example again. Let's take y is equal to e raised to x. So this is how your y is equal to e raised to x looks like. You remember the fractional part of the function, right? It is defined as, fractional part of the function is equal to x minus greatest integer of x. So literally, if you apply x term to it, you will get a sawtooth function, right? Now instead of applying x term to it, what I'm doing is I'm taking a function and applying that function to it. Clear? So if I apply the fractional part transformation to a normal function f of x, the function will become f of the fractional part of the function x. So in this case, if you take it, e raised to x will become something like this: e raised to x minus greatest integer of x. This will be the nature of the function. So what will happen to the figure of it? The figure will get truncated and it will become a repetitive function where the values the function e raised to x was taking between 0 to 1 will be repeated after each one unit, quite like you are seeing in the figure. So this is about your transformation using fractional part of the function. So let's summarize this entire transformation in one single slide now. So what are the different types of transformation you learned? You started with translation. Translation was nothing about moving the function along a straight line. So you spoke about you moving along the positive x-axis, which was y is equal to f of x, where f of x was transformed to y is equal to f of x minus a or f of x plus a, depending on positive or negative side. If you wanted to move it along y-axis, you transformed it as y minus b is equal to f of x, or y plus b is equal to f of x. That is translation. Then you did the transformation involving stretching and shrinking and magnifying and miniaturizing a function. How did you do that? So the function initially was y is equal to f of x. When you multiplied the x term or divided the x term, it became shrinking or stretching. So you made it y is equal to f of x by a or f of x into a. It was shrinking or stretching. If you multiply the y term, that is, you made it a into y is equal to f of x, or y by a is equal to f of x, it became a magnifying or miniaturizing function. So that was second transformation. The third transformation you did was flipping. You had a function y is equal to f of x. If you did y is equal to f of minus x, it got flipped along the y-axis. If you did y is equal to minus f of x, it got flipped along the x-axis. The fourth transformation you did was folding, where you just said that you apply the idea of modulus on the function. So what happened? It got folded from the negative side of the y-axis to the positive side of it. The next transformation you did was reflection, where you said that if I have a function y is equal to f of x, you want to reflect this function along the x-axis, you make it mod y is equal to f of x. If you want to reflect it along the y-axis, you make it y is equal to f of mod x. Then finally you did two more transformations, the more complicated, the more advanced one, where you said that you can do a transformation of a continuous function into a step function by just saying y is equal to f of x should be converted into y is equal to f of greatest integer of x, right? And you can convert a continuous function into a periodic function or a repeating function where only a part of the function is used as the repeating interval by using the fractional part of the function. So y is equal to f of x was converted into y is equal to f of x minus greatest integer of x. So that's all about transformation and about playing with graphs.